Hello, I'm John de Kok, and as the CEO of Technobis, I want to thank you for taking the time out of your busy schedules to attend today. Also, a big thank you to the global Technobis team in making this happen. We are streaming from Alkmaar in the Netherlands, the headquarters of Technobis Crystallization Systems. These are exciting times for the company, as this webinar marks the launch of a new standard in crystallization. The program of today will take about 35 minutes and covers the background, technical development, and application of our new instrument. We have a worldwide audience today, and we would love to hear where you tuned in from. So please let us know in the chat. Of course, you are also welcome to send in questions through the chat, and we will have a Q&A at the end of the program. Many of you may not know that Technobis Crystallization Systems initially operated under the name Avantium Crystallization Systems. And this company was founded in 2000 as a spin-off from Shell and had, with the introduction of the first Crystal16, already the backing of several industry leaders, among which Pfizer, GSK, Eastman Chemical, and AkzoNobel. Thanks to the strategic partnerships and investment from these businesses, we were able to create one of the most advanced chemical laboratories in the world and create a range of products that assist with medium throughput experimentation across a range of industries. In 2015, Avantium Crystallization Systems was acquired by its engineering, development, and manufacturing partner, the Technobis Group, and we became the business that you know today. And since that time, it has been our mission to help research succeed. And our platforms for accelerating crystallization research have been successfully developed and installed in almost every pharmaceutical research lab in the world. We currently have more than 600 units in the field, and more recently, we developed new applications in agrochemical, fine chemical, biofuel research, food, and even personal care. As a business, we are extremely proud of the enormous growth that we've been achieved over the years. In 2019, we outlined our 2025 vision, and part of our strategy was our innovation roadmap. This innovation roadmap is driven to help research succeed by investing more than ever in technology development to provide state-of-the-art research equipment. Many of you will already be familiar with our core product portfolio, but for those of you that are new customers of ours, we are extremely proud to offer the Technobis Crystallization Systems workflow. With our systems, scientists are able to perform well-controlled crystallization studies from hit and lead identification up through process scale-up and formulation, and they combine the crystal breeder, the Crystal16, and the crystal line in a flexible configuration. The reason we gathered here today is the complete new version of the Crystal16. So without further ado, I would like to introduce you to the Crystal16 version 3, the new industry standard. I'm proud to introduce the new industry standard to you, and we are looking forward to your response. Our CTO will tell you more about the technical development now, and don't hesitate to send in your questions through the chat.
Hello, my name is Stephan van Banning, and I'm the Chief Technology Officer at Technobis Crystallization Systems. I'm here today to share some insight into our latest innovation that will redefine crystallization and solid-state chemistry, the third generation Crystal16, the new industry standard. The desktop parallel crystallizer for medium throughput solubility and crystallization studies. Crystallization is one of the oldest separation methods in the world and has contributed to the efficient production of high-value products for decades. However, as I'm sure many of you will agree, crystallization chemistry is a varied and complex area of research that impacts each scientific discipline differently, sometimes for better, sometimes for worse. Crystallization is a crucial tool in synthetic chemistry laboratories for removing impurities that cannot otherwise be removed from a synthesis step. Or take formulation and tableting applications, where crystallization offers an effective method of producing particles with a specially engineered set of properties to produce the best performance in formulation and processing. However, crystallization can also be the troublemaker in the story. For example, in medicinal chemistry, where you want compounds to remain in solution and don't want crystals to form. The patient can take them as a liquid. In these situations, crystallization is unhelpful and stabilizing agents are needed to stop it from occurring. Studying crystallization was traditionally a time-consuming and resource-intensive exercise. However, we changed that when we introduced the scientific community to the original Crystal16 benchtop system already 17 years ago. Designed by scientists for the scientists, the Crystal16 has provided over 400 customers with a user-friendly multi-reactor benchtop system with simple, easy-to-use software for determining solubility curves, screening crystallization conditions at 1 milliliter scale. Our new Crystal16 version 3 builds on the success of the previous models with a series of technical enhancements and a streamlined unibody design, while as ever being designed by the scientist for the scientist. For example, one of our customers, a project leader at a big pharmaceutical research organization, said, "The user-friendly Crystal16 enables me to rapidly acquire large datasets on solubility, the metastable solvent width, and the induction time. This is exactly what we intended with this instrument." For years, the Crystal16 has provided scientists with a powerful system to simply use for polymorphism, salt, or co-crystal forming. Using 16 parallel reactors, users could test a wide range of crystallization conditions, such as solvent and solvent mixtures, compound concentrations, counter ions, and of course temperature profiles. With the new version, our completely new software offers improved research and analysis capabilities, while being more flexible, intuitive, and user-friendly than ever before. Furthermore, it will let you perform your experiments and analyze your data simultaneously in the same environment, making it our most efficient model yet. I know that a lot of you are probably thinking this all sounds great, but will require a considerable investment. Well, you will be glad to know that upgrading your laboratory processes to take advantage of our next generation analytical equipment does not have to involve an expensive overhaul of your entire laboratory. It just requires careful investment and a strong relationship with a reliable partner like us. We can help you identify the right instrument for your process, taking operational content, text such as budget, limited available space, and your in-house expertise. We are playing the central role in the crystallization ecosystem and supply more than just a device. We share knowledge and we share expertise. Now I would like to hand over to Dumitrescu, one of our highly experienced application specialists who's going to talk you through the applications of the new industry standard, the Crystal16 version 3.
Hello everyone, my name is Dumitrescu and I'm here to talk to you about the Crystal16 version 3, which we hope will become the new industry standard for crystallization research. My background is mostly in crystallization and chemistry with a focus on crystallography and analytical methods. In total, over 50 papers published in these fields. I joined Technobis Crystallization Systems last year in 2021 as an application specialist for the simple reason that I can readily use most of the instruments in my own private research. Last year, we celebrated 16 years of Crystal16. 16 years of having our main instrument on the market in various forms or iterations, and we were quite pleased to find out that the instrument has been cited as a critical piece of hardware in over 250 scientific papers, over 100 patents, and in total more than 400 units were sold, most of which are still operational in labs around the world. Now, who is using our devices, our Crystal16? The main beneficiaries is the pharmaceutical industry, where the Crystal16 has become a workhorse for any solid form screening laboratory, but also the Crystal16 has received a lot of interest from academia, where it has been used to discover the fundamentals of crystallization research. But overall, we can say that any field dealing with small molecule crystallization, agrochemicals, fine chemicals, or food chemistry can make use of our devices. We were also quite happy to see that other fields, which we did not initially expect, such as polymer chemistry, also made use of the capabilities of the Crystal16. We can also say that in some ways, the instrument has become the industry standard for solid form screening and for solid form development, as over 30% of top 50 big pharma companies have at least one of our devices in their laboratories, usually a Crystal16 or several. And this is because the instrument allows you to get information you cannot get from other sources. It allows you to do any type of solid form screening at a small scale. It allows you to measure polythermal solubility and get metastable zone information rapidly, as well as measuring nucleation rates and through experimental induction time measurements, as well as clear and cloud point determination. So, how do you improve the industry standard? Well, you take what is good and you make it better. But how do you know what is good and what do researchers value? And the answer is quite simple. You listen to what the research community has to say about your device. And in this case, we highlighted three main areas in which our device ranked highly among researchers. Everybody appreciated that the device was quite rugged and very reliable. Everybody appreciated that the device provided reliable experimental results in most experimental conditions of interest, and researchers also appreciated the custom data processing provided by the software specific for crystallization research. We took all these three aspects and improved upon in our version 3 of the Crystal16. We've improved the ruggedness and reliability through custom unibody construction. We completely redesigned the chassis. Not only does this give a more premium feel of the device, but it also improves the maintenance, the reliability, as well as allow you to reach lower temperatures with lower porridge gas consumption. We've improved the thermal stability and range of the device. Now you can reach lower temperatures all the way down to minus 20 degrees on all four reactors at the same time, as well as improving the analytics. Now the sensors have extended ranges, both in the high concentration marks and low concentration marks. Finally, we completely redesigned the data processing through a new software in which experiment programming and data analysis are integrated into one. Now, before I go into more details about these improvements, I'd like to remind everyone that at the end of the session, we'll have a Q&A talk. Please send your questions in the chat and we will answer them at the end of the presentation. So what you will get with the Crystal16 V3 package is a new software, completely redesigned, a new and improved hardware, but what we decided to keep the same, or is the same readily available consumables you can get from any commercial suppliers. The unibody construction. Previously, the Crystal16 was built from several individual pieces, and we decided to go for a unibody construction, one solid piece of machined aluminum, and this has quite a few benefits. Not only does it give a whole new premium look and feel for the device, but it also improves the reliability, the serviceability of the device, which leads to shorter downtimes for the equipment, but also to reduce maintenance. Because of the new unibody construction, we are able to control the moisture inside of the device far better, and this means a lot lower purge gas levels for the users and a lot lower maintenance costs. This means that with minimal cost, you can reach lower temperatures in the same conditions compared to the old device. We've improved the thermal stability and range of the device. Now you can reach -20 using air cooling on all 4 reactor blocks at the same time. However, if you want to go even lower, if you want to study crystallization at temperatures as low as -25 degrees, you have the option of connecting an external chiller for increased performance. We leave both options open on the device for you to decide which is more suitable for your system in particular. Not only does this translate to more information in the temperature ranges you are interested in, but also allows you to measure lower concentration. So if this is your experimental space, this is what you could previously measure using the Crystal16 version 2, and this is the experimental space you can measure using the Crystal16 version 3. Now, if you zoom in that image, and for example, this is a solubility curve of carbamazepine in technical isopropanol, this would be the range you could measure using the V2. And this is the range you can measure using the V3. You'll get a lot more information in the temperature regions of interest if you're designing a low temperature crystallization process. And of course, far lower concentrations. Speaking of lower concentrations, we've also improved the analytics on the Crystal16 in both the high and low concentration ranges. And by increasing the limit of detection in the high region, we allowed you to measure more turbid samples, darker samples, samples with particulate contamination, as well as potentially measuring 2 consecutive crystallization steps. By improving the low limit of detection, we decrease the minimum concentration which can be theoretically measured on our devices. If, let's say, on the Crystal16 version 2, depending on your crystallization systems, you could measure concentrations as low as 1 milligram per milliliter, using the V3, you can measure concentrations as low as 0.5 milligrams per milliliter. Finally, I would like to say a few words about our completely new redesigned software built from scratch. Previously, when conducting a crystallization experiment, you did the experiment programming and monitoring in crystallization systems, and then did the data analysis in the Crystal Clear. The feedback we got from the field was that although both pieces of software were completely fit for purpose, the workflow was a bit tedious transferring data from one piece of software to the other. That's why we designed Crystallization System 2, which is a completely new piece of software with both integrated functionalities. Because we have the advantage of thinking thinking of a new workflow starting from scratch, we redesigned the way in which you program the experiments. Previously, the system relied on a table-based system, which was accurate but sometimes tedious. Now we rely on a very intuitive drag-and-drop block system with even more functionality, such as repeating a block of steps a number of times. After you are done monitoring and programming and monitoring your experiment, you can directly go to the data analysis tab, where you can process the data, obtain your clear and cloud points, obtain your solubility curves. One feature we added here, and this was again by user request, was a custom clear and cloud point finding algorithm. The automatic transition point finding algorithm implemented in the Crystal Clear worked quite well in the majority of cases, but that did not cover all of the experimental space and all of the critical cases done by the research community. That's why for the new software, we've implemented a custom clear point and cloud point finding feature, where as a user, you can set your critical threshold parameters. So to conclude, whether you're interested in simple data such as solubility and metastable zone width, or you're trying to perform a solid form screening for polymorphs, salts, co-crystals, trying to see the phase diagram of your solid form, or trying to get information to design your scale-up, to have experimental nucleation rates to screen for a suitable solvent, then the Crystal16 is a very good instrument to have in your lab. I would also say almost crucial. And I would like to conclude that the Crystal16 version 3 is, in our mind, better in every way than the previous version. It gives you better, more accurate data. It gives you an improved quality of life. And finally, you can transfer these experimental data points using the integrated processing to real-world insights a lot faster. And because this, in the end, is our mission at Technobis, we are trying to help research succeed. Thank you. Thank you again for attending our launch. We received quite a number of interesting questions in the chat, and we will go through them one by one. So first question, did the current design have a significant impact on the temperature control? Stefan, I will pass this question to you.
Yes, thank you, Dan. I think I can answer that question. So good afternoon, all. Question about temperature specifications of the device. In the new design, we looked at the possibilities which are available to get the most stable temperature and proven temperature in all the environmental conditions. And knowing that the most common applications where our equipment is used for, the applications are around -20 degrees Celsius up to 150 degrees. And we looked into the possibilities to use air cooling, that you have no external chiller needed. But of course, it depends on the environmental conditions of your lab. So as long as those are at 20 plus minus 2 degrees Celsius, the air cooling is sufficient to have a stable temperature range, -20, 150, for the whole 4 reactor blocks. In case you are not able to control the environmental conditions, or you want to reach even -25 for all 4 blocks without any doubts, then you need to connect the system to an external chiller with not that much capacity needed. But then you are certain to reach it. Hopefully that answers the question.
Another question. Anything you can mention about the sensitivity?
Then I assume sensitivity also related to the temperature?
Yes.
Yeah, so also in the reactor design, we looked at the possibilities to have not only the 4 temperature blocks, but also for the 16 individual positions, to have as stable possible temperature. And that's based on the design, that you have a homogeneous temperature deviation combined with a calibration possibility in the system. So each and every individual position will be calibrated and corrected in the system to reach a couple of tenths of degrees difference maximum between the positions.
Thank you. Another question, does the new temperature range influence in any way the clear and cloud points? So I will answer this one. The existing clear and cloud point values will of course not change because these are thermodynamically defined, nor will the transmissivity. However, the new extended temperature range will allow you to record more data. So you will be able to characterize your solubility curves as well as your metastable zone width at even lower temperatures. This is especially true because in some cases we noticed that when the clear points are around 0 degrees, you need to go at lower temperatures, lower than -20 to -20, -25 to get the corresponding cloud point as well. Another question, will the existing users have to be retrained? Short answer is no. The users will find the hardware very familiar, same type of consumable, same type of steerers. Everything else we try to keep very familiar, and the software is highly intuitive. We had no issues in our internal testing of somebody using the new software and going back to the old one. Another question, can you mention a few applications of the Crystal16? As I mentioned in the presentation, most common application is polythermal solubility, but you can do a whole lot of experiments related to solid form screening, polymorphism screening, salt screening, preparative experiments, and so on. In any case, we will come back on the 31st of March with an extended webinar on the scientific applications of the Crystal16. Another question. Is the Crystal16 for designing of crystallization only, or capable of measure the type of crystals or polymorphs too? This is a complex question. What data you get from the Crystal16 is related to the transmissivity and the temperature. So you can infer the presence of a polymorph. Let's say if you run several consecutive heat and cooling cycles and you see slightly different clear points, that might be a good indication. You should check your material using diffractograms or thermal analysis. Can the software be installed on the server or client respectively? Can it be controlled remotely?
Yeah, let me answer that one. So the computer, the personalized computer, the laptop in this case, is directly connected to a system, but can also be controlled by a server or a network. The software that comes with the system can be installed on each individual computer with connection to a device or even at a virtual mode. Can it be controlled remotely? Yes. So if you are connected via your network to the computer that's in the network connected to the device, based on the IP address, you can perfectly control the device remotely. Yep.
Another question, is this potential helping record data where before was not possible? I guess this is related to both temperature and transmissivity. The answer is yes. We are able to measure at lower temperatures, so that means lower concentrations, and of course the transmissivity sensor has also been improved to give a better response at these lower concentrations. Nevertheless, we did not only extend the range at the lower concentration, but we also extended the range for more optically opaque samples, more concentrated samples. Another question, can you analyze data and run experiments at the same time simultaneously with the new software? Yes, you can run all 4 reactors and process your data simultaneously.
Yeah, maybe then, if I may add to that, this is also a nice analysis part. And for people who are familiar working with the Crystal16, know that you have the Crystal Clear software for the analysis of the clear and the cloud point that's now integrated in the software. So on one hand, you can see the real-time data, but also analyze the data of previous experiments while the system is still connected and running and collecting new data.
Can the new software be also used for the former Crystal16?
No, not.
Unfortunately, no. I usually take the data from the computer hooked up to the Crystal16 and load my data on another computer for data analysis. Will this be feasible with the new software?
It is feasible with the new software. What I tried to explain before is that you can have an installer on your personal computer and load the data, which is maybe stored on your network or an external hard drive. But now with the new software, it's also feasible doing that at the same installer, which is connected to the device, collecting new data, and you can open multiple, almost endless experiments for analysis while the system still collects new data. So it's not necessary, but it is indeed possible.
What is the minimum solution volume you need to measure transmission in the vials? 0.5 milliliters. We are still getting in new questions in the chat. Is there a possibility to add additional characterizations and turbidity in the Crystal16? Oh, this is a very interesting question. Perhaps
so additional characterization than the turbidity. Of course, the analysis part of the software now clearly shows the clear and the cloud points as a data output. And besides that, there is an expert use in the software, let's call it like that, where you can have information like nucleation time directly out of the clear and the cloud points detected by the system. Hopefully that answers the question. I don't know if you have something to add to that.
No. Still receiving additional questions?
Yeah, I can maybe give some more input or information about the turbidity. So besides the more sensitivity of the high sensitivity of the temperature, we also improved the sensitivity of the transmissivity measurement of the device, and that results in an improved detection of your clear and cloud point. So we are able now with the new device at the earlier stage to detect the first crystals, but also to go beyond samples which are darker or even higher concentrated than the original system was able to measure. And that in combination with the more accurate temperature control, that gives higher accurate data.
This is more of a general comment, I think. Okay. From the turbidity data, one can understand much more than just clear and cloud points. I fully agree with this comment. However, I would take great care not to overinterpret the data. Feel free if you have other questions. Feel free to send them in.
Okay, then seeing that there are no new questions are coming in, of course, people can always send an email to us or to info@crystallizationsystems.com, and we will be more than happy to answer them.
And of course, if there are no more questions, we would like to thank you for attending the Crystal16 version 3 launch, and we are looking forward to hearing your feedback. The presentation will be sent to you via email. As I mentioned previously, on the 31st of May, we are having another webinar specifically dedicated to the applications of the Crystal16, both from a theoretical point of view and a practical how to conduct the experiment on the device point of view. Thank you a lot for watching, and have a nice day.
Thank you for attending. Goodbye.